Let's put my video on so you know who is talking at the moment. So I'm Bernard Pinty. I'm going to chair this morning, both sessions. So yesterday we had quite an interesting day with one session focusing on the issue of policies and international dimension related to the Paris Agreement. Then we have more scientific technical sessions about what we do in terms of flying satellites, being ready with ground segments, and the interpretation of and the analysis of the concentration measurements that we make from space. This morning we have two sessions. First one with 4 speakers, and the focus will be about in situ, and it's quite an important dimension of what we are trying to set up, as you will see in a minute from the various participants and these presentations. Then we'll have a break, and we'll have a quite challenging session on the international dimension, which also is a big part of our activities. So I hope you had a good afternoon, a relaxing evening, and you are up to speed for this morning. Maybe before giving the floor to Eric, actually I'd like to ask Gail, if you could show quickly what done with Slido and how can participants make use of it. Thanks, Gail.
Yes, of course. Thank you. First of all, hello everyone. I hope you're doing well this morning. Today I'm going to explain you quickly how the Slido works. So you will be able to access Slido with your phone, either by scanning the QR code on this site here, or if you go to slido.com and access the event through the access code Copernicus for CO2. Once you are once you did that, you will be forwarded to this website, which you see here. Here, please don't just put your name in, but include also the country and or the institution where you're from. Once you did this, you will see here you can join the event. And once you did that, you will arrive on this page here. On here you will see type your question. You will be able to type any question that you have during the sessions. Your question will then be reviewed by our moderators. So you will see the status of your question on the right-hand side. So you will just have to wait a few moments for the question to be approved before receiving replies. Once the question is approved, other participants can upvote or like the question. If this will happen, then the question will be, it will be a popular question and be more on the top. Once our moderator has answered to your question, you will see the answer right below. And lastly, we also have polls like the word cloud that you saw just before. When we have a poll open, you will be able to switch at the very top to the live polls. And you can also switch back to the Q&A. So this is how Slido works. I hope this is very clear for you. And yes, you can ask questions at any times to the presentations who are ongoing at the moment.
Okay, thank you, Gail. I hope that's clear. In fact, we are a little bit concerned by the number of questions that was asked yesterday. I mean, expecting more, although we had quite a lot, but still. It's probably the case that we are going to deal with sort of WebEx and Slido or equivalent for quite some time. I mean, we are not yet ready to get together in a meeting room and enjoy the the good coffee from the Commission. So it's better make sure that everybody is familiar with the system. We're going to start with this first session on in situ, and that's a session which is really dedicated to what are the needs, what do we need to do, what are the limits in the current system we have, what are our expectations as well, our wishes. And here, you know, that's particular, let us say, in the direction of the other member states, because they have quite an important role to play in that context. So with no further ado, I will give the floor to Eric. Eric is going to be the one who is now in Brussels helping us on the CO2. He will be the basically responsible for this file. Eric, the floor is yours. Thanks.
Thank you, Bernard. And good morning, everyone. Welcome to the in situ session. As you heard from Bernard, we have 4 talks this morning, and I will introduce the topic in a general sense in this first talk. Why do we worry about in situ observations? Well, that's because the key user requirements cannot be met unless Copernicus has access to essential in situ data. That's a quote from Henrik, who will be speaking shortly after me. And that's the motivation for also my talk today. So we have a very good documentation of the needs for in situ and the needs and the importance of in situ data and the role that they will play within the Copernicus CO2 monitoring and verification support system capacity that you heard about yesterday. So this report that was issued last year in July, it's called the Green Report, and it analyzes the needs and analyzes the importance of in situ data in the future service. It identifies 4 areas in which in situ data will play a role. Firstly, to calibrate and validate the space component. So the radiances that the satellite will measure, these need to be calibrated with ground-based measurements. Some of the ground-based data will be assimilated in models to integrate information into the core system, in particular to be able to separate fossil fuel emissions from other emissions. Third area of use of in situ is to validate and further improve physical models that govern the evolution of CO2. And finally, the outputs, the products of the service will also need to be evaluated and verified, so to check that they are fit for purpose for the end user needs. Another further point to make here is that it's not necessarily the same observing stations or the same networks or even the same parameters that we need measured for each of these 4 steps. As I mentioned in the first step, it's radiances that you measure. At the bottom one, we would need measurements in exactly the quantities that the output parameters are. So there's already quite a lot out there. There are measurements of greenhouse gas fluxes from the ground, greenhouse gas concentrations in air samples from towers. There are atmospheric soundings from the ground. There are air samples taken from aircraft, and there's ground-based remote sensing. We need to, as I said, measure CO2 in the background air, CO2 in the plume, also the ratio between carbon-14 CO2 and normal CO2 in order to estimate the proportion of CO2 emission that comes from fossil fuel sources. And there's also a need to measure co-emitted species, because that also helps to attribute the source of the emission. And of course, the monitoring and validation support capacity exploits data assimilation, as we heard yesterday, particularly from Richard Engelin's talk, to integrate all this information into model framework. That means that not everything needs to be measured everywhere, but through model assumptions and continuous data simulation, you can bring in information and bring it forward in time through the process of data simulation. So there are some particularly strong challenges, I think, to do with this future service. Firstly, the sparseness of existing networks, and I think also the recognition that the existing networks were set up to serve partly different purposes than the one that we are addressing with this in this context. The CO2 MVS capacity will focus on estimating the emissions from fossil fuel emissions, which is difficult. There will be a focus on urban areas, large cities, and hotspots. Of course, measurements of the environment, biological emissions are also of interest, but here there is an increased focus on urban and power plants and other hotspots of emission. There are, of course, ambitious goals to determine the country by country, for cities and hotspots, and also, as we heard before, there's a need to provide consistent measurements across regions and for the entire globe. There are issues around funding, sustainability, and governance. I have a further slide on this topic in a moment, but there are challenges there, partly because many of the existing networks are operated on a research basis, and we need data on an operational basis. So I suppose one of the conclusions of the Green Report is that insufficient in situ networks would be a significant risk for the performance of the future service. So the approach generally, when it comes to addressing observation requirements, is to first assess current in situ networks, what we have in the current situation, what's the current capability, and then quite an intricate step is to try and quantify the requirements of the future service. This has to be done through modeling and simulations to simulate the performance of the service in terms of emission accuracies under different scenarios of in situ observations in conjunction with the projected accuracy of satellite observations. And once you've done that, you can conduct gap analysis to compare what you need with what you have, and then in earnest address the gaps. I'm not saying that we should wait necessarily to address the gaps until we've reached this point. There are things that we can do before, but this is the basic sequence, the logic sequence. And this needs to be done for, in particular, the satellite CalVal, and also for the operational needs of the service. So we carry out network design studies that is planned for the ongoing and future Horizon Europe projects. Horizon 2020 was CHE, and Horizon Europe is COCO2. Promote investment in infrastructure at national level. The way we can do that most directly is to address the requirement to the delegates of the Copernicus Committee. You will hear in a moment that we are developing cooperation with ICOS, which is another avenue to address this, and of course working with EEA. I'll come to that in a minute. Legislation is a possibility. If we go to the greenhouse, if we go to the air quality side, legislation is in place to ensure that measurements are gathered from urban areas across Europe. Enhance governance, adopt best practices. Perhaps the strongest partner we can have there is WMO. Make operational. That is to upgrade research infrastructures to provide operational dependent observations. So I've listed a number of acronyms down there of agencies that we will be working with. In Copernicus, the setup is such that Copernicus relies predominantly on existing in situ data capacities. There's no possibility, I think, for Copernicus itself to invest in ground-based infrastructure. That's not part of the remit of Copernicus. Instead, member state organizations and many other in situ infrastructures and data are essential contributions to Copernicus, but Copernicus is the user of those data. So the space component can be tasked to provide some in situ data for CalVal in response to the dedicated mission needs. Copernicus in situ component is run by EEA. We will hear about this in the next talk. And they provide access to in situ data serving the Copernicus services. So Copernicus services, ESA and EUMETSAT work directly with in situ data providers to collect and control observations needed to produce and validate their products. See if I can move to the next one. Yeah, so this is my final slide. And I'm hoping that this will provide a smooth sort of link to the next 3 talks in this session, where I mentioned first the most obvious opportunities that we have identified so far is to build upon the ICOS network. ICOS runs an effective station network, and this was set up with involvement from the European Union as an ERIC, a European Research Infrastructure Consortium, which is run by DG RTD, and we will hear about that from Agnes in a minute. And there are plans to integrate into this framework the observing network called TCON, which is very valuable for calibration and validation activities within Copernicus, to integrate that within ICOS. There are existing urban networks such as C40 and EEIONet managed by EEA. And there are opportunities there to extend those in the direction of measurements of greenhouse gases and CO2 in particular. And then the most immediate opportunity is the Green Deal call managed by DG RTD, which we'll hear about as well in Agnes' talk. So with that, that concludes my presentation, and I'm looking forward to seeing if there are any questions in the Q&A on the Slido side. As you heard this morning, the Q&A side of the workshop is a very important element, and I will have a good look at any questions and try to answer them. Bernard, over to you.
Yep, very good. Thanks a lot, Eric. That's a very nice overview that you have been providing. With very insightful comments, by the way. So next is Henrik. Henrik is from EEA, and as you know, EEA is in charge of the in situ networks and data sets for the Copernicus program. Henrik, the floor is yours.
Thank you, Bernard, and thank you, Eric, for an excellent introduction to this important topic. Good morning. My name is Henrik Sten Andersen. I work for the European Environment Agency, where I am responsible for the cross-cutting coordination of the Copernicus in situ component. So my presentation will focus on 2 topics related to the implementation of the in situ component of the CO2 monitoring and verification support capacity, namely the role of the EA vis-a-vis the Copernicus in situ component, which was already mentioned a bit by Eric, and then also the potential involvement and contributions from the European Environmental Information and Observation Network, or IONET, to the CO2 MVS in situ component. So, needless to say, to meet the objectives, essential in situ measurements are needed to establish an operational monitoring and verification support capacity to quantify anthropogenic CO2 emissions. green report underlines two important facts. The availability of sustained in situ networks is essential for the fit-for-purpose European CO2 monitoring capacity. However, as also mentioned by Eric, the existing networks are currently not capable of delivering all the essential observations in a sustainable and coordinated fashion. Consequently, in situ measurements need to be extended under a coordinated European lead with dedicated infrastructure and targeted additional and sustained long-term funding. So before discussing in what way the European agency can contribute and support the Copernicus CO2 MVS capacity, let me summarize just a few facts about the agency and its network. The main objective of the European Environment Agency, or simply the EA, is to provide sound, independent information about the environment. It has 32 member countries and 6 cooperating countries, and aims to support sustainable development through the provision of timely, targeted, relevant, and reliable information to policymaking agents and the public. The European Environment Information and Observation Network IONET is a partnership network of the EA and the countries. The EA plays a strong role in Copernicus, where jointly with the JRC is responsible for implementing the Copernicus Land Monitoring Service. Furthermore, the EA is also responsible for the cross-cutting coordination of the Copernicus in situ component, and we focus on establishing and maintaining an overview of the state of play of in situ data in Copernicus. We focus on operational provision of selected cross-cutting in situ data. We manage partnerships with data providers, and we are supporting the European Commission and the Copernicus entrusted entities. However, it is also important for me to underline that the majority of the Copernicus in situ data activities are in fact performed by the services ESA and EUMETSAT. So, through the IONET, the EA brings together environmental information from individual countries, concentrating on the delivery of timely, nationally validated and high-quality data. The exchange and sharing of environmental data is embedded in EU legislation or high-level agreements between the EU and respective non-EU IONET member and cooperating countries. So, as regards monitoring of the air quality in Europe, EU member states and EEA member and cooperating countries measure pollutant at monitoring stations in compliance with the ambient air quality directives. These air quality measurements are reported by IONET members and hosted by the EA, and consist mainly of up-to-date or near real-time, if you want, measurements coming from automatic samplers, and also validated measurements from both automatic and manual samples submitted annually by the end of September. And all these data are available on the EA's website and also in a number of reports. So, making the CO2 MVS capacity ready for 2026 is a huge and complex task, as we heard yesterday, but also an essential contribution to the Green Deal. It is important to underline that the holistic approach or system approach taken by Copernicus to ensure the successful definition, implementation, and operation of the CO2 MVS capacity also has a considerable impact on the in situ component. At the same time, this approach enables us to identify and make full use of existing in situ observation capacities in Europe and globally, and it gives us the opportunity to identify gaps and propose mitigating actions in good time before the operational phase. The EA, in his role as coordinator of the Copernicus in situ component, has taken some steps that are relevant for the CO2 MVS capacity. First, a workshop was organized April last year and hosted by EUMETSAT, At the workshop, European space agencies and data users met with representatives of TCON and other networks to discuss the sustainability of these networks, which will form a crucial component of the CO2 MVS in situ component. Secondly, as a result of this workshop, and because also this is so important, a report on the sustainability of European greenhouse gas calibration validation networks was prepared and released to the public January 2020. And finally, the EA also asked the IONET experts to prepare a report on how urban IONET in situ infrastructure can contribute to the CO2 MVS in situ component. The final report was delivered this month, in fact, and we will make it publicly available after the review process has been finalized. In the following slides, I will now try to summarize some of the key conclusions of these two reports. So, first, as regards calibration validation data, I would like to mention that ground-based remote sensing observations of column greenhouse gas from the total carbon column observing network, or TCON, are essential for the calibration and validation of current and future greenhouse gas observations from space. Consequently, it is of highest priority to identify sustainable funding for the European part of TCON. Also, the Collaborative Carbon Column Observing Network, or COCON, has demonstrated its value for campaign-based observations, but has also potential for complementing the ground-based calibration validation network, especially for emission monitoring of hotspots. And also, minimum requirements for greenhouse gas calibration and validation data need to be defined by the space agencies and the Copernicus services. And as we saw yesterday in a presentation by EUMETSAT, this work is actually already underway. So, furthermore, at this workshop in April 2019, the report and also in the report, three possible pathways for achieving long-term sustainable greenhouse gas calibration validation observations were identified. You could consider the fiducial reference measurement network as an integrated part of the CO2 mission. You could see it as an integrated part of ICOS, and also mentioned by Eric, or a combination of both. But it's important that to understand that to achieve a sustainable solution, it is fundamental that all stakeholders, including Copernicus, ICOS member states, TCON stations, are supportive of that solution. But regardless of the chosen model, and a comprehensive implementing strategy and plan for the transition phase should be prepared to pave the way for the operational phase of the CO2 MVS capacity. I'm sure that Werner Kurz from ICOS will inform you about these activities in the next presentation. So, let's have a look at the air quality observations. IONET and the EA serves as a data repository for measurements reported by EU member states and EA member and cooperating countries. Consequently, IONET represents a relevant in situ network due to the CO2 MVS capacities need for urban data on co-emitted species. In accordance with the sampling standards set out in the air quality directives, IONET provides in situ observations of tracer pollutants from European cities. Currently, around 3,400 stations are active all over Europe. IONET could provide a stream of high quality and sustained urban in situ measurements of co-emitted species such as NO2, PM, and CO. These air quality observations and the subsequent sharing of the data are embedded in EU legislation and could therefore be sustained in long term. However, further assessment is required to judge whether these potentially useful data are fit for purpose. So, plans in the EU's Green Deal to evaluate the current air quality legislation may present an opportunity to explore potential improvements in air pollution measurements that would benefit both local air quality monitoring and the CO2 MVS capacity. The CO2 MVS in situ component will require coordination and governance at European level, as well as additional observing capacity in particularly urban areas. The EA and IONET could play an important role, as is also the case for the delivery of up-to-date air quality observations to the Copernicus atmosphere monitoring service. So, cities are considering the adoption of measurement-based greenhouse gas emission monitoring to facilitate the compilation of inventories. This presents a very important paradigm shift. Therefore, it would be pertinent to focus on a dialogue with the respective municipalities through fora such as the European Covenant of Majors. Such cooperation could benefit both sides, in fact, providing support to the local planners wanting to implement the measurements, while at the same time ensuring that the technical requirements of the CO2 MVS capacity are met. Additionally, together with the EA, formal data sharing mechanisms can be developed and which may allow for a sustained stream of data into the CO2 MVS capacity. So a few concluding remarks. The Green Report identified a set of key actions. First, the Green Report makes it clear that it is necessary to ensure the sustainability of essential networks such as TCON and others. The EA could support the process through analysis and coordination actions performed as part of its role as coordinator of the Copernicus in situ component. Secondly, the report says that there is a need to enhance existing network capabilities to include new observations such as radiocarbon and co-emitted species from fossil fuel burning. IONET, as you have seen, possesses expertise, system, and infrastructure components that could be reused and support the CO2 MVS in situ component. And thirdly, the Green Report points to the fact that there is a need for adequate governance schemes to be coordinated at international level. The EA and IONET focus on coordination at the European level and could potentially therefore support the overall coordination of the CO2 MVS in situ component. And by that, thanks for your attention.
Thanks a lot, Henrik. That's quite an interesting series of ideas and proposals that you are coming up with. So now I leave the floor to Werner Kuch, who is responsible for the integrated carbon observation system. It's quite an important network for many of us. Now, floor is yours.
Yes, but I can't see the presentation now.
It's coming in a few seconds. I'm sorry. It takes a bit longer. I'm very sorry for that. It's being shared with you.
Okay, while it's coming, I'm briefly introducing myself. My name is Werner Kuch. I'm the director of the Integrated Carbon Observation System, which is a European research infrastructure. And as such, it is somehow long-term sustainable and was built by many European countries with the support of the European Commission to build up this measurement. How to move this? I think I have found it.
Yes, perfect.
It's small on my computer. Well, I would like to take up what we have heard yesterday. What's the challenge when it comes to in situ measurements or in general in observations? The challenges are that we have to integrate not only over CO2 but several greenhouse gases and co-emitted species. You can see this in the this symbol graph that you have not only CO2 but also methane, NO2. We might also look for N2O. And these greenhouse gases, these different species, are emitted from sources that are varying in time and space. What we also need to know are the biogenic fluxes. We finally are depending on what is ending up in the atmosphere, and you perfectly know that not all the emissions are finally ending up in the atmosphere. There is a discount that we get from natural ecosystems and oceans that is more than 50%. And if you want to understand the anthropogenic fluxes, we also have to understand the biogenic fluxes. What we are in the end looking for is small changes in large fluxes. We can see this in the current shutdown due to the COVID-19 pandemic, that we can count from statistics the decrease of the emissions during this shutdown, but in principle the signal compared to the large still existing emissions, but also to the concentration in the atmosphere and to the biogenic fluxes, is almost not detectable when we are looking at only at the CO2 concentration. And we have to integrate complex information. This means we have to integrate over a lot of data, and we have to integrate via models, and we need a respective data infrastructure and modeling infrastructure. There is another challenge. When I look at this graph, it's showing a constellation of satellites, but there is nothing about the in situ component in this graph. And I took this as an invitation for my presentation to introduce a little bit the in situ component by using this graph. So let's zoom in. So you see here the symbols of perhaps a city, but also of agricultural land, and it can be perfectly related to the different sectors where the emission reporting are done. But there's one sector missing, and that's the power. So I have added it there. We still have a lot of emission related to the generation of electrical power. And when it comes to the in situ networks, we require sun and wind, and not because we want to have solar power and wind power. We need this for our measurements. And I think the graph is a little bit misleading, that it has distributed the gases. Very often we have all the gases in the same plume, and it's important that this that we are measuring them together, because we want to also look for the co-emitted species and ratios between CO2 and N2O or other co-emitted species. And I think this is a very important and valuable information. So what are the elements, the in situ elements? I think the first one, and perhaps important one, are atmospheric observations, and we can put them upwind and downwind of a city or of an emitter, and with that we can detect the emissions between these two towers, and we can do this for CO2 or all the other gases, but we can also do this with isotopes, not only 14C but also 13C CO2, which gives us some kind of information about the sources and sinks of the CO2. So this is I think the important one important approach, and you can see here an experiment or a pilot, a series of pilot measurements that we have done within a EU Horizon 2020 project called Ringo, and there we have put we went to emission hotspots like the whole city of Paris or the industrial area and city of Rotterdam and the Neckar area, which is highly industrial, and we have put two measurements, upwind and downwind of this area, where we really follow the air parcels and take a C14 sample at one point at the upwind point, and then 3 hours or 5 hours later at the downwind point. And these are very interesting results we're getting from this. But of course, the wind direction has to fit, and if it's not fitting, we can't do these measurements. So a ring of perhaps 4 or even 8 measurement stations around a city would be perhaps much more efficient. The same counts, of course, for the normal atmospheric towers. Now going on with the atmospheric observations, there is a already mentioned tool, the so-called FTIR spectroscopy, which is looking directly into the sunlight and is then analyzing at the different bands the absorption that is coming from specific gases. And this is a very important and valuable information, because it is the satellites are using the same technology with reflected light. So this is the already mentioned TCON network that is providing this information and combining this with atmospheric measurements and putting it in a same array. For example, around the city would be a very nice approach, and that's why we are currently finding ways to integrate this into ICOS. And I'm coming to a second element, that are direct flux measurements. You may you see these little flux towers in the agricultural field, but also close to the car, and these are really measuring the direct CO2 fluxes coming out of an area within the city, not the whole city, but with an area within the city, and also from a crop field, and there you get a lot of information. I want to give you one example that is also related to the COVID-19 shutdown. These are eddy covariance measurements, urban eddy covariance measurements from 8 places inside urban places within Europe, Basel, Berlin, Helsinki, and so on. And you can see on the left side the picture of the Helsinki flux tower, which is very close to my office. And so I'm seeing this every day. And you can clearly see that the fluxes have been reduced during the shutdown. But there is also a lot of differences that have to be analyzed depending on the place where these towers are within the city, but also depending on the city itself and on the severeness of the shutdown. So this is an example of the technologies that we have. I want to add one more graph related to the COVID-19 shutdown. You see here an ensemble of curves with December and January in the middle, and this is the so-called winter peak of the CO2 concentration in the atmosphere, taken from the state, in this case from the station Lindenberg in Germany. And you can see that very often in these winters you have 2 peaks, one in December, November, December, and one in January, February, sometimes even in March. And that the 2020 curve is a little bit different. This late winter peak has not been it's perhaps a shoulder, but perhaps it's even not showing there. And then compared to the other years, the decrease in the CO2 concentration in February, in particular in February and early March, is faster than in the other years. And then in the end of the curve in May, it's perfectly in the middle of the other curves again. So can we see the COVID-19 shutdown? The answer is no. It is not a signal of the COVID-19 shutdown. We had a very warm winter and an early spring, and we had a different transport, different weather and transport patterns, and this is giving this curve. So when we are looking for specific events for reduction of CO2, anthropogenic CO2, we always have to keep the biospheric fluxes in mind, and they can drive the curves and the concentrations even much more than a severe reduction of the emissions as we had in the last weeks and months. I want to add one more part. You see a box that's called monitoring. Henrik Steen Andersen has introduced the IONET very well. So I think the cooperation between all these components and all these players is very important, and having data streams from the monitoring into the scientific infrastructure and into the modeling is, I think, a very important part. So I'm coming to some kind of a conclusion or a bit more about ICOS. You see, I have added all these elements to the graph. We are a long-term sustainable research infrastructure. So currently there are 12 countries participating. 3 more are coming in 2020. We have been built on investments of about, I think it's more than 100 million euros. We have a 25 million euro annual budget, which is mainly used for running 130 in situ stations for atmosphere, ecosystems, and oceans, and you have seen a few results from them. We were built a bit more with a focus on background information, so going towards the hotspots is at the moment more in pilot projects, more in research. We have to learn a bit more about how to look at these hotspots, and but we have this in our strategy. We want to build on our experience and on the investments to have these measurements of hotspots also in our portfolio. We can build on a very high standardization of instrumentation, but also quality assurance, quality control, data processing, and data provision to the users. As mentioned, we are currently negotiating to integrate TCON into ICOS, the European TCON stations, and we also have a strategy to develop and integrate city observations, and we definitely want to coordinate a pilot observation. You might hear about this in the next presentation. The problem that we have in ICOS is that these 130 stations that we have built up are very important and very valuable. If we want to add more, like city observatories or integrate the TCON, this is not possible by shifting internal money away from the existing network into a new network. This needs new sources of funding, and we are currently looking how this can happen. This also needs a strategy to move perhaps a little bit away from the poor research budgets or the pure research infrastructure budgets, and look for cooperation, for example, with the monitoring networks, and get some more stable funding there. I think that's most of the information I want to give you, and I'm happy to answer questions or organize meetings to go more into details of the future strategy and perhaps future plans of ICOS, but also on whatever you want to know about ICOS. Thank you very much, and back to Werner.
Thank you, Werner. That's another interesting talk that we have this morning. Actually, I like the way you have been commenting on this little logo that was made by non-specialists, but checked by people who are supposed to be in the field. Actually, what you mentioned is extremely important, the cohabited species that we missed on that graph. We're actually doing something in that direction also from space, as you have heard yesterday from Yashka. We're flying also the capacity to have observations of methane and N2 as well, to help us, in better identifying the flumes. So the next talk is from a colleague of mine from RTD. This is Agnes Olobine, sorry. Agnes, she will tell us, about this European research infrastructure, which are so important for everybody, especially in Europe.
Thank you, Bernard, and good morning to all. Thanks for the opportunity to present activities from European Research Infrastructure Action in the Commission. I realize that the title is a bit misleading. I'm not speaking on behalf of the European Research Infrastructure, but on behalf of the Commission and its policy on European research infrastructures. And I will move to... and by the way, there was a reference to this drawing not from specialists, and I'm not a specialist in CO2 monitoring. I prefer to mention it from the very beginning. So I will firstly present the general policy context for the Commission on research infrastructure or approach, say a few words on the European Strategy Forum on Research Infrastructures, which is an important body for on multilateral initiative on infrastructures and known for its roadmap. And then I will move to framework program support under Horizon Europe and the current Horizon 2020 Green Deal call. This one. Sorry, coming. Yes. So I guess the policy context is already well known. We have the Commission priorities, the 6 priorities. Just more recently, of course, due to the current situation, all the planned activity linked to the recovery plan. And I just want to mention briefly that for research infrastructure, we are also acting in the context of the renewed European research area. That's important to keep in mind. And we expect also our Commissioner reminded that the role of research and innovation in the Europe recovery is quite vital. And in this context, the Commission proposal on Horizon Europe has slightly increased to take into account the new challenge linked to this to the current situation, with some focus on health, but also on resilience, Green Deal, and digital transition. About research infrastructure, so research infrastructure are not monitoring systems, so facilities, resource services that are used by research communities to conduct research and foster innovation in their field. So that's quite obvious, but of course we encourage this infrastructure to be used beyond research, in particular for education and or public services. So this is important to keep in mind that the focus is on research, but we try to have synergies and use beyond research. Research infrastructure are by nature quite diverse. We can have major scientific equipment or sets of instruments, but a huge part of infrastructure are actually knowledge-based resources, collections, archives, scientific data. And of course, we include the infrastructure part with data and computing systems, communication networks. What is important to notice is that in the context of the Commission, we are mainly interested in the infrastructure with a kind of unique nature that are essential to achieve excellence in research and innovation. Of course, infrastructure can be single-sited, and more we see, in particular in the S3 roadmap, they are virtual or distributed. I would actually said virtual and distributed. That's an increasing development of research infrastructure in the recent years. These are, I believe, quite obvious that I would like to remind the central role of countries in developing and funding research infrastructure. So all the development, the construction and the operation costs are mainly in the hand of the nations, but there is a need to have an approach at European level. And you have here example of the reason why, in particular for the development of new infrastructure, you have to address the complexity and the, in principle, huge cost for construction, not only construction, but operation of these infrastructures. Transnational access is still an issue, despite many years of support and promotion of transnational access. Risk of duplication, interoperability issues, exchange of best practice, even training of new users. These infrastructure are complex and they are difficult to manage, so training of infrastructure managers, technicians, trying to address pooling of resource, to promote pooling of resource, and so on. So our main line of coordination between the Commission and the Member States is the European Strategy Forum on Research Infrastructure. The Commission is a full member of this forum. It's promoting a multilateral initiative to develop, to have a strategy on research infrastructure at EU level. It has been instrumental in promoting development of national roadmaps. So you can see that more and more you have more and more countries developing their own national roadmaps and creating synergies with the European S3 strategic roadmap. We have developed a specific legal form to facilitate the implementation and the operation of the infrastructure at European level. And also we have worked on developing principles and guidelines on access policies. That's the European Charter for Access. Of course, we have the support and specific action under the successive framework program, Horizon 2020, and soon Horizon Europe. We are also promoting synergies, in particular with regional priorities and smart specialization. Also promoting international cooperation and global initiatives. So I guess you have heard about the S3 roadmaps. Here you can see a picture of the infrastructure prioritized by S3 from the very beginning, 2006. You can see that S3 is covering all scientific fields, digital infrastructure with praise for high performance computing, energy, of course, environment, health and food, physical science and engineering, and social science and humanities, called now social and cultural innovation. Just as an example, I would like to mention, for example, EuroArgo, because it's an instrumental facility for example, for Copernicus, for the in-situ component of Copernicus. And it could play a significant role in the CO2 monitoring because it's developing its biogeochemical component, and it could provide essential information on CO2. This is just an example of a major infrastructure already implemented. More recently, you can see new infrastructure that have been prioritized by S3, such as actors for cloud and trace gas component in the atmosphere. The FTIR for ecosystems research. Just to mention that recently S3 has issued a white paper providing key message on the role of research infrastructures and also on the role of S3 in developing this landscape of European research infrastructures. Horizon Europe, as under Horizon 2020, research infrastructure are part of the first pillar under excellent science. I will just like to highlight that despite being in this cross-cutting first pillar on excellent science, a major change since H2020 is that we will more address global challenge. In the past, we were quite bottom-up, cross-cutting, mainly supporting, as it will be still the case, the different phases of the development of research infrastructure, the design, preparatory phase, implementation phase, and now possibly early phase operation. But we will also develop specific support to diverse class of infrastructure, pending that they can address global challenges. So supporting transnational access, but also support to customize their services to address specific challenges, societal challenges, global challenges, and it's rather new compared to our past action. Moving, I'm just checking the time. So we, to some extent, we are anticipating Horizon Europe with the Horizon 2020 European Green Deal call, because we would like to provide some specific support in the context of research infrastructures. The call, maybe you have heard about it, you are aware that there will be 8 thematic areas, more or less reflecting the different priorities under the European Green Deal. And they will target very specific high-impact technological and societal innovation to advance the sustainable transition relatively quickly. So that's short-term impact. In addition to these 8 thematic areas that I will show in the next slide, there are 3 more cross-cutting areas, one on strengthening the knowledge, another one on empowering citizens, and the third one on international cooperation. So they are complementary to the thematic areas, and these areas, horizontal areas, offer a longer-term perspective to achieve the transformation set out in the European Green Deal. Nevertheless, they are quite focused topic in these areas. So here you can have a more precise overview of the call with the 8 thematic areas or vertical areas and the 3 horizontal areas. And I will focus on the area 9 because it's there where we can I can present the topic 9.1 on addressing research infrastructures in particular. So the title of this topic is European Research Infrastructures Capacities and Services to Address European Green Deal Challenges. The title is very specific, but the content of the topic is quite focused in line with the European Green Deal call approach. The first subtopic is to support European leadership in clean energy storage technologies. And the second subtopic is to support the European research infrastructure and monitoring networks for greenhouse gases, observing air quality and citizens' health in and around cities. So there is a strong focus on cities and hotspot for emission. 2 main lines of actions: enhancing European research infrastructure for greenhouse gases observation. A second line on air quality in European areas. So we expect a proposal to address either the first line or the second line. And in addition, both lines should also include a roadmap for upscaling. So focusing on the first line, the objective is really that this action proposed under this line should enhance greenhouse gases observation capacities of European research infrastructure, notably anthropogenic CO2 emissions in and around cities and other large emission sites such as industrial sites or transport infrastructures. If I just can move, so I was late with moving to my slide. What is important is a bit for research infrastructure, it's a bit, the topic is a bit out of the box, because normally we would support the design phase of new infrastructure or upgrading infrastructure, and we would at a later stage envisage support to the implementation. So this call was the opportunity to together under the same topic and the same project, the design, conceptual work, and the pilot implementation. So here we are mentioning pilot implementation in at least one representative urban site, and we expect the proposal to set out preliminary selection criteria and to refine this selection criteria possibly during the action, and to address how to select this site. Just to mention that we, in the topic under discussion, we have made explicit reference to Copernicus, to CO2 monitoring task force, and also to the CO2 green report. We are also referring to specific European research infrastructure in the mainly those in the S3 roadmap, but it is not exclusive, meaning that any appropriate observing system could be part of this action. And I think I'm close to the end. Just a timeline. So the topic is under discussion. We have recently received, so this is discussed and should be validated by the strategic configuration of the Horizon 2020 program committee. There was a public survey that ended early June. Normally, we should have the adoption of the formal adoption of the Green Deal call in September, as well as the amendment of the Horizon 2020 web program, and the publication and opening of the call in September as well. In principle, you will have under the ERA days, is this virtual event in September, opportunity to find or to further develop contact for potential project partners. And normally the deadline for submitting project proposal is expected end of January. And I'm closing here, some key messages. More and more we expect research infrastructure not only to deliver on excellent science, but to deliver on political priority areas. So under Horizon Europe, we will keep the support to infrastructure just based on scientific excellence, but also based on a more targeted approach to support European priorities, in particular climate change and sustainable development goals. We also expect to develop further synergies between infrastructure and different Horizon Europe priorities, missions, partnership, and other relevant initiatives. And of course, Copernicus would be a major target to develop synergies with. For us, in our unit, European Green Deal Call is also the opportunity to test a more targeted approach compared to the past framework program. And of course, I would like just to mention that the pan-European governance for research infrastructure, for example, ERICS, should facilitate synergies with Copernicus, with different initiatives, signing of memorandum of understanding and decision making. And national funding, key message, remain central in everything. Thanks for your attention, and I'm available for questions, of course.
Thanks a lot, Agnes. You are coming with good news with this call. I'm sure people will be extremely motivated by answering and proposing some good action and activities in that context. So we're very well on time. We have planned for like 15 minutes discussions or at least answering questions before a small break. The idea that sort of questions we have now are sort of, really related to the session and sort of really directed towards the different elements we heard today. And it looks like from the questions we get on the slide that there is quite a number of concern about uncertainties, quality assurance, quality control data sets. And I wonder, Eric, could you say something on that, please? So we have a larger view maybe on what's happening there.
Yeah, hi. I saw those questions as well about the interest in having clearly quality controlled data sets. I suppose I can just begin with the elements of an answer, and I will hand over to Werner, who's actually operating a network, and he should be able to add to my answer. All I want to say is that obviously for data users, it's essential that all data are associated with an estimate of uncertainty. So there's an onus there on the network operators to provide with the data good estimates of its uncertainty. In addition to that, there are things you can do if you have any type of redundancy. So if you have two networks measuring the same thing, you can start to compare data sets and get something from that. Another very powerful approach is to use a modeling framework to monitor systematically the data that you receive and compare them with modeling results. So by doing that, you're integrating information from many sources, and that can often allow you to spot spurious trends in data. Assuming that the model doesn't exhibit the trend, then trends you see in differences between model and data is due to trends in the observations. Finally, I know that there's a lot of interest also in having uncertainty estimates on the output products of a service, such as this. You know, we need to be able to assign uncertainties on the CO2 emissions, finally. And the approach to take here is to carry out ensembles of estimations. And those ensembles, the ensemble techniques, they rely on having good estimates of the uncertainty of all the inputs to the modeling system. And I'm saying that here because those inputs are exactly the observations that the system uses, in addition to uncertainties on the model system itself, so model error, we call that. So for all those reasons, from a user's perspective, you need to have uncertainties. Right, so that was a kind of an umbrella answer, but I hope that Werner will be able to say something more specific as a network provider.
Well, I can say a lot about quality assurance, quality control. It starts with the calibration of the instruments, or it starts even with the calibration of the calibration gases. So we are connected to the WMO standard. We have central labs also to avoid the differences between laboratories when it comes to the analysis of gases or to the production of calibration gases. We have a lot of quality assurance and quality control processes in the data processing, and this is all documented. So usually you have a lot of metadata or can get more on request that are really showing the whole chain of quality assurance and quality control. What we, of course, where big uncertainties are coming from, let's say this way, is that we cannot put an eddy covariance station to every forest, to every crop field, to every grassland. So there are uncertainties coming from the coverage also of the atmospheric stations, and even more from on the ocean stations that we are providing. The ocean sink, for example, of the Southern Ocean is very uncertain because we simply don't have, and Euro-Argo also doesn't have the density of measurements that we need. So I saw one question, if I can, if this perhaps is sufficient, but I saw one question that was asked by Nadine Gobron from the GRC. How to get quality control in situ data outside of Europe. And I would like to say that we are having a very interesting week. We are currently having 2 workshops, one in the morning here and the second one virtually in Geneva, organized by WMO, on global cooperation and good practices on greenhouse gas observations in cities. And this is very interesting to jump between the 2 workshops, and I see part of the participants who have been there in the last days in the WMO workshop are also here. And there we are sitting as a global community organized by WMO at the table, and we are exactly trying to get standards on a global level, get good practices on the global level, and there are many other global data services or global data initiatives that are also taking care of this. For example, FluxNet or SOCAT, where we also have tried to get a lot of quality control and standardization into the global networks. So there are global efforts, and I think through these global efforts we are ensuring the quality but also availability of the data from other regions.
Thanks, Anna. Thanks, Eric. Actually, I'd like to ask Richard. Richard, can I put you on the spot to see what's your view when we have to deal with different systems, different uncertainties, different quality of data sets? How can you manage that, into the system, the MVS that you are going to be setting up? Can you say something on that question, please?
Yeah, I can try. Can you hear me?
Yeah.
Okay. Well, this is obviously a very complex topic. There were a few questions in Slido, and I noticed Hugo was also answering some of this. And because it is complex, it gets quite a bit of attention actually already within the different developments that are being carried out, both on the observation side, as Werner already explained, but also in terms of developing the overall MVS capacity. So within the research projects we are carrying out now, we have specific tasks on looking at how we deal with the uncertainties, not just in the observations, but in all the components, because in the end, we want to deliver products with a good accuracy estimate. But because we are putting together so many different information sources, this is just very complex. So this is certainly something that needs more attention, more development in the coming years to make sure we're doing it right. But it's being addressed and being worked on.
John?
Yeah. Yeah.
Okay, thanks.
Yeah. I mean, I can go on for another hour, but I think this is
fine. No, we have few of us have facing connection issues, so I don't know. Well, I think we are pretty much done with this technical discussion. Well, we can always come back later on. What I propose now is to have a break, 10 to 10 minutes. So let's say we can be back probably at 11. So 11, we'll start with the last session of this workshop. Thanks. Delia?
Yes.
The answer was false. I mean, executor is really fast, and I have no clue what.
So you cannot access Slido?
No.
Okay, I will ask my colleagues at MCI to provide support. But we can't really properly hear you.
Ugo, Bernard just sent me a text that he has connection. He's having problems reconnecting.
I'm back on the air.
Okay.
I can share the session, but I'm blind regarding anything like questions or emails.
We are sending you a new link, Bernard.
Okay, if you could do that, that would be fine.
Yes.
Please send it to my both emails, email and the corporate one. I will try to manage when we start.
Yes.
Okay. So we are probably ready to start again. Now we are going to have a discussion about international dimension of our some background somewhere. I don't know where that's coming from. I don't think that's coming from my side. Anyway, yes. So I was just saying that we have this last session. You have seen that the workshop is organized with these 4 sessions, and we are getting now to the end. Obviously, not the least. I mean, it's quite an important dimension because we have a few other countries who are actually interested in that topic and dealing with CO2 measurements as well. We need also this umbrella, from international organizations to help us and actually contribute. So it's really my pleasure to have Joe Post starting this session. And with no further ado, Joe, floor is yours.
Thank you, Bernard. Hello, everyone. Pleasure to be here. Thank you very much to colleagues for inviting me. I'm going to talk today about the UNFCCC Convention and the Paris Agreement, particularly relevant decisions and conclusions around research and systematic observation, data provision, and climate services. Speak to you a little bit about reporting under the Paris Agreement and how the reporting that previously has taken place under the UNFCCC is moving into this new reporting arrangement. A little bit about the global aspect of the global stocktake, which measures collective progress under the Paris Agreement, and then summarize at the end with the coordination, the collaboration that we urgently need to work together in this systems approach to meet the goals of the Paris Agreement. So the convention in '92 called on all parties to achieve stabilization of GHGs in the atmosphere without impacting the climate system. And it has specific commitments under that convention, including in regards to scientific information. And Article 5 is actually specifically focused on research and systematic observation and the need to promote and cooperate in observation of the climate system to support and strengthen observation and exchange of data and take into account the particular concerns and needs of developing countries in this work. And under the UNFCCC, there's a specific agenda item, research and systematic observation, that deals with this engagement from the scientific community to the policy community. And this is the engagement happens through a value chain, which is shown here on the slide. This need for observation, for research, the assessment by the ICOS, which is very important to our process, all feeds into this sort of policy box. And within that policy box lies individual action by parties that needs to be supported, as well as decision-making at the global level by bodies of the convention, the subsidiary body for scientific and technological advice, the subsidiary body for implementation, who then advise the conference of the parties and the conference of parties meeting in regards to the Paris Agreement and meeting in regards to the Kyoto Protocol. And under the RSO item, research systematic observation agenda item, there is an exchange through reports, through statements, through mandated events such as the research dialogue and the Earth Information Day. So here I wanted to try and provide you a little bit with the overview of what the Paris Agreement actually looks like. And it is an ambition cycle. This year, the nationally determined contributions are due to be provided, either updated or renewed by all parties under the Paris Agreement. Alongside those nationally determined contributions are adaptation communications, some of which are included as part of the NDCs. There is also a requirement from parties to provide long-term low GHG emission strategies alongside their NDCs. And this is communicated, so this is intention of parties, and of course the action has to be taken in which to meet those intentions, so there needs to be action on mitigation and adaptation. And then under the process, at the international level, the parties then provide a report, and the report under the Paris Agreement is part of this enhanced transparency framework. The first report is due in 2024 and every 2 years following that, and will include a huge amount of information, but part of which is the GHG inventory, part of which is progress on NDCs. And then this individual national effort will be assessed every 5 years, starting in 2023 in the global stocktake. And I'll provide a little bit more information on that. But the outcome of the global stocktake then informs the updating of the NDCs in a nationally determined manner. There's a progression clause in the Paris Agreement. Parties shall update NDCs with the mind to ambition, and this 5-year cycle carries on. And observation is a huge part of this basis. Without the observation, without the data support, and so on, none of this could actually happen. So here are just a few of the major decisions and conclusions that have taken place under RSO that are relevant to colleagues here in the workshop. We, of course, rely heavily on the GCOS implementation plan, and Simon, I'm sure, will speak with that in a while. There is a decision from 2016 which urges parties and others to implement that plan. But then in regards to monitoring greenhouse gas concentrations, this was recognized in the SBSTA conclusion in 2017, which noted the increasing capability to monitor greenhouse gas concentrations. There's also recognition following on from that of the integrated greenhouse gas information system and the need to work in a systematic way to support WMO to fulfill those intentions there. The need, of course, to enhance development of climate services was also recognized. And then last year, we had the Earth Information Day in Madrid, which was extremely successful, and thanks to colleagues at Copernicus also for engaging with that. And the SBSTA welcomes this huge role that the scientific community has in collecting, managing, opening, sharing data, and providing process data products, urging parties and organizations to continue to do so. And to also recognize the SBSTA also recognized at this time the systems approach of the constellation architecture by ICOS, and the need to, again, work systematically together in collaboration to fulfill that work and the opportunities that provides for parties in their engagement, particularly in GHG inventories. I've put here links, which I hope are live when my presentation is published, which gives you a long list of all of the conclusions and decisions actually on our agenda item. So if we go back to the Paris Agreement and the reporting there on GHGs, the Paris Agreement enhanced transparency framework, some of which is still being discussed at the political level, but essentially there will be a movement from developed countries, developing countries, having separate ways of providing information to this unified approach to the biennial transparency report. The review process will also be streamlined a little, and of course there's the need to provide reports to review those reports, and then obviously as a general facilitator, multilateral consideration of all of this information. And this slide gives you a little bit of an overview of the architecture of those transparency reports. So that in the three blue boxes really show you the three steps to that reporting, and then the text within those boxes shows you whether parties shall or should. So shall is they definitely have to, should is they ought to, hopefully they will. And of course, GHG inventory and the progress on the NDCs is the key element of that one of the key elements of that transparency, which will also be reviewed. And the multilateral consideration process will bring people together to ask questions about that in a working group session. I wanted to show here from the developing country perspective a huge challenge they have really in providing reports under our process. We heard yesterday, of course, that the EU is well organized in providing GHG reports. This is not the case for many developing country parties. Some already are not even using the 96 IPCC guidelines. The Paris Agreement mandates recognize the 2006 IPCC guidelines. But of course, there's a lot of work to be done in supporting parties actually meet their requirements and be able to provide their GHG inventories in a systematic way moving forward. And SIDS, small island developing states and least developed countries actually have a clause within the mandate to say they provide their enhanced transparency framework as soon as possible. Everybody else by 2024. So I've just gathered that sort of information here on this slide, and that there was, of course, a refinement to the 2006 guidelines last year. That's been recognized under the SBSTA, under the research and systematic observation mandate, but actually is not yet recognized as a point that the parties need to consider in their GHG inventories, and that's worth encouraging and supporting moving forward. the new information provided in the refinement. And of course, a key part of that was the components and steps that the observation community can help with in supporting the GHG inventories. On top of the transparency framework, some of the information that will also be still carried on, still reported, is that the enhanced transparency framework is biennial. Developed country parties, including the EU, will still need to provide annual GHG inventories. There's also the national communications, which come every 4 years, and as well as the RED Plus reporting will still carry on top of the ETF enhanced transparency work. So here's just a very broad guideline of we're moving from the old reporting system. This year, parties are due to provide their new or updated NDCs. The first global stocktake, which will take place in 2023, will happen actually before the transparency report, and I'll speak on that in a moment. And then those transparency reports will be provided into the second global stocktake and so on. So the global stocktake is a global level approach to assessing progress. It has to take information that's provided on a national level and bring that to some sort of comparison, if you like, of what's happening nationally compared to what's happening globally, and provide messages and communicate messages to increase ambition moving forward. And the global stocktake will take place in 3 clear steps. There will be an information and collection and preparation phase where everyone important input will be provided into that phase by constituted bodies under the convention, by the substitute and FTI chairs, and by a range of UN organizations and so on. And that list of input is actually in the decision CMA 19 CMA 1. And then there'll be a technical assessment phase, which brings in this information, and there'll be dialogue within, co-facilitated dialogue within that, which will also consider the IPCC assessment. And then in 2023, there's a high-level consideration of the output. The global stocktake will be approached in a thematic way. So it will look at these 5 themes. It will look at the mitigation, including in that the overall effect of the nationally determined contributions and the state of GHG emissions and removal and mitigation efforts undertaken by parties. It will also include, as you can see, adaptation, finance, equity, and other issues around loss and damage and response measures. And here is a very, very broad guideline of what the global stocktake looks like. Like I said, here is the 2021, it will really start happening, so the information will be received. The SB chairs will provide guiding questions for each three stages of the global stocktake. And there will be a summary report from the technical dialogues that will be provided into the consideration of outputs in 2023. Of course, as everyone knows, there's no COP or SB sessions this year, so there will be some discussions at a higher level about this numbering at the top of this diagram here. But more than that, I don't know at the moment. So one of the things that the Secretariat is working with and discussing with the observation community is how is it possible that the observation community can provide input into the global stocktake in a meaningful way. And one of the ways that we would like to suggest is a coordination group, if you like, to help provide input into the global stocktake, perhaps bringing in some discussions with colleagues supported by the Secretariat, looking at how the observation community can help, what can be provided that's useful in a thematic way. For example, which countries are using Earth observation for GHG inventories and in which way, and clear case studies to illustrate that. Where can parties access the key data that they need or the services that they need? And there is an opportunity here, I think, for the observation committee to provide a synthesis of what into the GHG. Of course, the exact contents must be decided, and I'm looking forward to working with colleagues around this. It's a where are we, where do we want to go, and how does observation help us get there conversation. And I hope that we can build that moving forward in the next year. So just in summary, one of the important questions that really comes to mind is for many is, can we measure carbon dioxide concentration accurately enough to support parties in reporting under the enhanced transparency framework? And if that's the case, how do we build the capacity and understanding to do that? Of course, I put in brackets here on the left side of your screen, this workshop is focusing on carbon dioxide, but this question, of course, goes to Copernicus data support more widely. Of course, it's not just carbon dioxide to consider under the greenhouse gas reporting on the co-emitted species. There's a conversation to be had around opportunities for follow, as well as adaptation and loss and damage. But Copernicus can support party reporting, that's clear. It can support it for methodological support, including GHG inventories and emission estimates. Perhaps can support parties in understanding ICOS methodology, or at least providing the appropriate data within that context. The review process is also an entry point. There will be an urgent need for a greater number of reviewers to review countries' inputs into the enhanced transparency framework. And that process actually involves advice to those countries who have provided their reports to say, you know, this is a way of doing this better moving forward. And the urgency, of course, is to support developing countries within this, and we recognize the collaboration that we have with WMO and ICOS in this regard. Copernicus can also support the global stocktake. Of course, on the party level, parties will provide their reports, provide advice to the constituted bodies, who will also provide reports into the global stocktake, and as I mentioned, collaborate on a global level for a synthesis report. And I think that one of the key takeaways I had from yesterday is the importance of the systems approach for monitoring, reporting, evaluation, and for the global stocktake. So the carbon dioxide and methane reporting is, of course, a priority, as was highlighted yesterday. But it's important to think, you know, with the GHG flux, can we look at perhaps how this occurs over areas where there's forestry, where there's obviously a huge focus on biomass by colleagues in the observation community. But can we look at GHG flux in this regard if we're talking about engaging in agroforestry, in looking at ways for reducing carbon dioxide? Is there a way of actually quantifying this? So I just want to say thank you very much. I'm looking forward to answering any questions that you will have, and remain, of course, available, not just today, but moving forward to engage further in this exciting work. Thank you.
Well, great thanks, Joe. That was extremely interesting. We've been learning some new things, and the last slide is of particular interest to whoever is dealing with Copernicus. It's very encouraging, actually. So thanks a lot for this update. We can appreciate, you know, level of complexity of the system we're dealing with when we get to UNFCCC sort of level. And well, I'm sure now we'll get an interesting view, the one from WMO, GCOS. GCOS has been partner with Copernicus for quite some time, and that includes obviously the strong links we have related to the climate change service, which is one of the drivers of this CO2 initiative. Simon was also kind enough to provide reviews and insightful reviews on the reports that have been mentioning yesterday. You know, the blue, red, and green reports. So Simon, the floor is yours.
Okay, thank you very much for that. The slides I'm going to present, were a lot of them are produced by Han Dolman, who is our new chair of the GCOS steering committee. So I thought I'd start just by reminding people what GCOS was about and the GCOS mandate. GCOS itself was founded in 1992, but the Memorandum of Understanding between the 4 co-sponsors of the programme in 1998 puts the goal of GCOS to provide comprehensive information on the total climate system, and that's covering physical, chemical and biological properties over the atmosphere, ocean, hydrological systems, cryosphere and terrestrial processes. And also we're intended to meet the needs of quite a wide range of users, from climate system modelling, climate change detection, monitoring impacts and responses to climate change, also providing data for application to economic development and research toward improved understanding, modelling and prediction of the climate system. So we cover both from the climate science idea into much more policy orientated users. GCOS does this by identifying what needs to be observed and defining the requirements for these observations. And these are the essential climate variables, ECVs. We try and monitor how well these are being observed and identify any gaps and issues, and also identify actions or areas for improvement in the observational system and try and help them to be implemented. This slide shows our work plan for the next couple of years. It is targeted around the timescale of the UNFCCC Global Stocktake. Currently, we're producing a new status report, and that's the review of the observing system. How well are the different ECVs actually being observed? What are the gaps and areas for improvement? And we're aiming to have a public review of that in the first part of 2021, and then the report will be finalised through the year and published. We've also started looking at updating our implementation plan, which is where we look at identify areas for improvement and what needs to be done to try and improve the observing system. We've already had a public consultation looking at the requirements for ECVs at the first part of this year, and our experts are looking at the comments that were received and reviewing the requirements, and they will be incorporated into an implementation plan through next year. So we're hoping to have a report to be reviewed, publicly reviewed in 2022 for publication that year. Also, as part of that, we're intending to have a climate observation conference in October 2021. It will be held in Darmstadt in Germany, with the aim of trying to get more inputs from a wider observational community. There are a range of activities that are ongoing as well. So we're continually reviewing the observational system, looking at gaps and progress. And we're also extending our activities to look at how the observation systems can support monitoring impacts and responses to climate change. We've been doing quite a bit of work as well with regional support, regional workshops, looking at what needs to be done in specific parts of the world. When we look at the ECVs, we're actually trying to monitor parts of the climate system, or the climate system as a whole. And there are 4 parts that we've particularly identified that need to be monitored well. There's the water and carbon cycles, there's the energy balance, and then there's the biosphere. And we need to measure those fairly completely. We've set targets for the long-term monitoring of each of these cycles, and the slide shows the targets for the carbon cycle. These are overall targets for the cycle as a whole, including not just the fluxes, but also changes in stocks and so forth. But it's important to remember that the individual ECVs must also be consistent within the cycle and between cycles. A lot of ECVs are important for more than one cycle. So, for example, evaporation is important in the water cycle, is also important in the energy cycle. And we also have to be aware that ECVs are measured for other purposes, and we want to avoid duplication of effort. So a lot of ECVs are related to meteorology and weather prediction, for example. So if you think about CO2 fluxes, this is a chart taken from the IPCC's 5th assessment report. And if we look at, say, the area for Europe, the regional predictions for Europe, it's clear that the comparison between the estimates made from fluxes and the more inventory type approaches, the uncertainties are very large. The ecosystem models don't necessarily include land management, nitrogen deposition effects, but even so, there are probably too few stations which result in the errors. The other area I've highlighted here on South America, in fact, the sign is wrong in the fluxes, and this is reflecting the fact there's no stations in the appropriate region. So there are large discrepancies, or there were in terms of the IPCC's 5th assessment report, and the uncertainties are of a similar size to the actual budgets. We've seen some of these slides before, and these are some of the observations. There's the observation network from Gore, and there's the ocean network, SOCAT, looking at partial pressures of CO2. And these networks are expanding and being improved, but are vital to actually making these estimates. You can also see that for the ground-based stations, there are larger numbers in the northern hemisphere and fairly sparse coverage in much of the southern hemisphere. These are other observation systems, many of which have been mentioned, ICOS and the total carbon column observing network, and these are obviously important measurements. There's measurements being made from aircraft, and obviously they are probably not being made at the moment, or very few. And then there are new technologies, new abilities looking at carbon column measurements as well. So the observational system is developing and is improving, but probably maybe not completely sufficient. This is a chart that was published, I think, in 2018. And essentially, it's a metric showing the sensitivity of the estimated fluxes to the observations. It shows how well the observations can constrain the flux estimates. And you can see for the surface measurements, the estimates of fluxes are fairly well constrained in North America and Europe. That's the top row. It's a bit patchy and seasonal in parts of Asia. For the bottom two rows, the satellite observations, they are much better at constraining flux estimates over the tropical and extratropical areas, but not so helpful in much of the northern hemisphere. So we can see that the different types of measurement currently, as they stand, influence flux estimates differently in different parts of the world and regionally. So from a point of view of GCOS and looking at how we are reviewing the situation, there are significant gaps in the observing system, even in Europe. And there are significant differences in the sensitivity of the estimates of surface fluxes to measurements between observing systems and modes. And these vary both spatially and temporally. So surface measurements have little sensitivity to the tropics in the southern hemisphere, and the satellite observations are good, high sensitivity to tropical and subtropical fluxes. Another point that's coming out of the satellite observations is maybe the Earth system isn't behaving entirely as we thought, and there may need to be a need to rethink some of the ideas. These charts show the persistently high anomalies of column CO2, particularly over some of the tropical forests. And this would imply these aren't sinks at all, maybe even sources. And similarly, over the tropical oceans, there are persistent negative anomalies. So the satellite observations are revealing that we may need to have some more thought about how the system is working on a global scale. This was done in 2019. So obviously looking at the Paris Agreement and the needs of monitoring CO2 fluxes and anthropogenic fluxes, an important part is the fossil fuel CO2, and you can see from this chart that the fossil CO2 can be a very small part of the overall fluxes. This is, which in this case in North America is dominated by the biogenic sources. So it's quite difficult just from CO2 to estimate, CO2 observations to estimate CO2 fluxes. This chart highlights this. The black line is a fairly high resolution CO2 inventory in North America. And the blue dotted lines show inversions based upon CO2 alone, and there's not very good agreement at all. However, if you include observations of carbon-14, you get much better agreement. And the carbon-14, as we've heard, is a marker for fossil fuel use. And so making estimates using not just CO2, but also carbon-14 and maybe also NO2 and other traces, we can much improve the estimates of fluxes. Looking at the overall landscape of monitoring the carbon cycle and carbon fluxes, there's a whole different range of interests and stakeholders that feed into our thinking. There's a whole different societal dimension, from citizens through municipalities, as we've heard. There's also the private sector. There's policy making, high-level decision makers such as the convention, and there's science. And they have slightly different needs and perspectives. And there's also a whole range of different scientific observations that can contribute to looking at observations of ecosystems, oceans, as well as the atmosphere, gases, and so forth. And it's important as we work forward with the safe spot and implementation plan that we keep this in mind. And if we think about just the scientific landscape, there are some whole range of different bodies and groups looking at different parts of the system. They're very diverse scientific domains, and often these have specialized approaches and their own different ways of addressing it. And this needs to cover both the carbon cycle and greenhouse gas fluxes and climate change as well. And we need to look from GHG inventories to carbon fluxes, but also think about biomass inventories, what's happening in the ecosystems generally. So there's a vast range of different groups. And at the moment, a lot of this isn't very well coordinated because they are very specialized, they have their own interests, but there's no real overall coordination across this whole range. So to conclude, despite large improvements in the in-situ networks, there are still big gaps in key areas of the carbon cycle, both in the ocean and on land. Satellite information is improving and may be suggesting some counterintuitive ideas, which obviously will need more thought and consideration. There's an increasing emphasis on fossil fuel detection after the Paris Agreement, and this will require the in-situ networks to look at fossil fuel traces, such as NOx and carbon-14. But also the whole landscape of monitoring is very fragmented both science-wise. That's often due to the complexity of the carbon cycle itself, but also politically, and we realise there's a lack of coordination, and hope that we can at least stimulate some way of improving that. So with that, thank you for listening to me.
Thanks a lot, Simon. That was, as usual, quite interesting and enlightening. I think we can now proceed with the last talk of this session, the last talk of the workshop, and very happy to give the floor to my colleague and friend, Mark Dowell. Mark, please.
Yes, Bernard, thank you. Can you see my slides?
We do.
We can, Mark. The slides are there.
Okay, I don't see them at the moment, but
it takes a little while to come to Italy.
Yeah. Okay. Sorry about this.
Can you see it now, sir?
No, I'm not seeing. I just see the grid of participants.
So.
Are you sure you need your slides?
Yeah.
So I'll share them again.
Mark, would you like to share your screen? This can be done as well.
Yeah.
You know how to do it.
I'm not on my. I'm not on my desktop machine. I saw it for a moment, and then I didn't see it anymore.
I will share them again, and we'll see if you can see them. Can you see the slide now? Live Q&A and polling?
No.
No, neither. Okay.
As I said, I did see them for a moment, and then I lost them.
Yes. And now?
Maybe I should stop my video a minute. No. Okay. Can I ask you to advance them, and I will advance them in tandem on my screen so I know where we are.
Yes, perfect. Let's do that. I'm sorry for the inconvenience.
I see it. Hang on. I see it now. I see it. Okay. That's good.
Okay. So you can see them, but you won't be able to change the slide. So I'll do it for you.
That's fine.
Okay.
Okay.
Yeah.
So, yeah, thank you very much again, Bernard. And thank you, of course, to Joanna and to Simon, because I think they've provided a very good context for what I'm going to talk to you about briefly now, which is really, if we think of everything we've seen over the last couple of days, and in particular the policy context, well, the policy and program context that we seen in the last two presentations, how we have kind of approached this in really engaging at the international level. And of course, this is a long-term endeavor, and we've started off in certain areas, but of course that doesn't exclude that we're going to extend this kind of level of engagement in other areas in the future. So if I could have the next slide, please. So I just want to go back. Bernard yesterday gave, I think, a very good overview, basically, of the timeline we've followed so far, and the timeline that we see into the future in the implementation of the system. And if we think back to the Blue Report, so the kind of the genesis of this adventure in 2015, there were kind of four cross-cutting aspects that were really kind of emerged from this, and many of these have been addressed in detail the other day. The first is really this emphasis on a system approach to what we were doing. The second was that although we realized there was a lot of research and development that still need to be done, and I think that it's fair to say that we have made some investments already in that area, but eventually our intent was to develop an operational system. The third point, which perhaps should really be the first, is that as with all aspects of Copernicus, this should be driven by very strong user requirements, which based both on international commitments from the European Union member states, as well as the kind of the implementation of these commitments in the context of EU policy. And then finally, and this comes to this presentation is that we really recognized back in 2015 that we couldn't do this without really engaging immediately in kind of strong discussions, dialogue, partnerships with our various counterparts in different organizations and entities at the international level. Next slide, please. So what's the approach that we've taken? And this is, of course, in very broad terms, but we've tried to establish partnerships that are both kind of in the policy context at the international level. And that's one of the reasons why we've invited Joanna and Simon to kind of start off this session. And also, and more perhaps most actively with our counterparts as data providers and peers on the implementation of various aspects of these systems. At the same time, we also have tried to address these or look for efficiencies in both creating partnerships with both multilateral entities and bilateral discussions with third countries that Copernicus as a program has agreements or partnerships. And really to try and identify which of these is most effective in the different cases and in the different necessities, let's say, for implementation of the system. To be clear, this has not just been an effort from the European Commission, our partner organizations, ESA, EUMETSAT, ECMWF, and many, in fact, of the member state agencies, such as the space agencies, have also played a role in this. And we've tried to look where we should perhaps take leading roles in some, for example, technical working groups or things like this, so that we could really kind of make sure that things are progressing in a way to be beneficial to what we're trying to develop in Europe. It's obvious, and I think the Eric's presentation and that session in general made very clear this morning that there's a strong international dimension, of course, to the in situ component as well. And we need to prioritize partnerships on those aspects specifically, both, for example, with colleagues at the WMO in the context of GOR and ICOS, and also in our discussions with bilateral countries. So it's not just about exchanging satellite data, but we also need to think in those bilateral discussions how we optimize the in situ aspects. And then finally, we need to think, especially for not only for what we're developing at the EU level, but also outside of the EU, how we can basically operationalize both some of the data access, both for the satellite and in situ access, so that the systems that we're developing, or the system that we're developing, can take best advantage. So next slide, please. So I won't go into detail on this because Joanna gave a very thorough overview of the different steps and the different kind of, I would guess you could say, accomplishments that have been made by the systematic observation community over the last years in getting relevant conclusions into Subster. But just to say that we have remained engaged throughout these discussions. Already, I believe, back in Marrakesh at the pilot for the Earth Information Day, Bernard gave a presentation on our intentions and ambitions, and we've remained engaged both in these kind of side events and Earth Info Days, and also in contributing material to our parties in the delegation for the negotiations. Sorry. Next slide, please. With GCOS, of course, there's has been, as Bernard alluded to before, a very strong partnership there, which predates our efforts on the CO2 initiative. And in fact, I think back, I was thinking yesterday evening, it was already back in 2010, 2011, and Stephen Briggs will remember this because I remember him being at those meetings. We recognized that the GCOS and the essential climate variables provided an incredible template basically for us to organize our activities within Europe, and much of the definition of the Climate Change Service came from looking at guidelines, best practices, and the climate monitoring principles that underpin the GCOS program. At the international level, of course, we've also been very engaged in not only kind of contributing to the GCOS process, both in defining implementation plans and things like this, but also in looking from the space agency perspective through CEOS, the Committee for Earth Observation Satellites. We can make a coordinate, we can use these requirements and actions coming from GCOS as a basis for really defining a coordinated response to this from the space agency perspective. So it really has become, almost like a template for collaboration at the international level, provided by the very precise and recurrent process that GCOS provides. Next slide, please. So while that's changing, is it changing for anyone else? Because I can't see it changing. Hello?
Yeah, we have actually the slide which is entitled Action in GCOS IP 2006.
Yeah, could you change the slide, please? Okay, I don't see it changing. While they're changing that,
not changing.
Okay, well, while they're sorting that out, I think I can remember what comes next. So in 2018, the Commission chaired the Committee on Earth Observation Satellites for the first time, and we established a number of priorities during that year of chairmanship. Amongst and the first one, the kind of the top priority we identified was really to lay the foundation for an international CO2 and greenhouse gas monitoring system, this so you should see it now. And so here you see the kind of the three main actions that we kind of committed to advance and push forward in the context of that year. The first one was to make sure that an ongoing activity already within CEOS, which was this idea of the atmospheric composition constellation paper, was completed, and that was under the leadership of Dave Christ from NASA JPL, and that was completed in the context of that year. To really look at the synergies between the kind of the research developments and the more kind of operational frameworks and developments by establishing a stronger relationship with the Coordination Group for Meteorological Satellites, CGMS. And so there were a number of discussions and meetings and on how to better push forward with that coordinated response. And then finally, to organize a workshop really trying to look at the interfaces with the other aspects of the system that we were needing to implement. Of course, the space agencies, as we saw yesterday, can really only directly control a specific part, but we wanted to make sure we knew and could develop further the necessary relationships and interfaces to the modeling community, the in situ community, and the inventory community. Next slide, please. So just starting off with that workshop for a while, one interesting thing, and I know a number of colleagues on the line today were at that workshop, was that there was a fair amount of time discussing terminology, and I suspect that's always the case. But you can see here the kind of the two headline. There are obviously different levels of sensitivity from one country to another, but this was kind of the consensus that we could come to, really that these efforts we were undertaking were to help countries improve their estimates in CO2 and methane emissions and removals in support of their nationally determined contributions under the Paris Agreement, and to provide additional mechanisms for validating the consistency between reported emissions and the output of the system. So this was something, as far as kind of our common ambitions at the international level, something people could agree on. If we can go to the next slide, please. A second thing from that workshop was, you've seen this diagram many times over the last 2 days, but it's not quite the same, actually. Well, firstly, there was agreement at the workshop, a common agreement across the agencies that we should go forward with a system approach. You will see the diagram, although reflecting that the same type of system approach that we are proposing in Copernicus, there's a couple of subtle differences. Firstly, in the top observation box, of course, there's a specific reference to the international constellation as the basis for the space-based observations. And you'll also see in the outputs box that there are other carbon cycle products as one of the primary outputs expected from these systems, insofar as there are different countries, of course, that have different priorities at the moment on what type of products they would appreciate. Next slide, please. So this just gives you, I'm sure many of you are familiar with this. This gives you an overview of the Constellation report and a link to the document. This was a massive undertaking and really compliments to Dave Crisp, who led this activity. It was 88 authors from 47 different organizations. So and that provides really the basis for much of our work now going forward. Next slide, please. Here you see the three main actions from the report. Firstly is really about looking at linking atmospheric greenhouse gas modeling communities, so really kind of the integrator to provide a first set of products. The second point is really about exploiting the capabilities of different actors, CEOS and CGMS, but also, of course, the activities within ICOS at the WMO, and to come up with a first kind of pilot product for the first global stocktake, and then as a later step to really think about evolving that in a more operational and sustained context for the second global stocktake. Next slide, please. As I mentioned, we also put a fair amount of effort over the last few years into starting with that chairmanship of the European Commission of CEOS on how to better coordinate the activities internally, and we're currently developing a roadmap. And here I should also compliment, apart from ESA and EUMETSAT's very strong involvement on this, but also many of the agencies from the space agencies from the member states, including CNES, DLR, and of course the UK as well, have engaged quite strongly in these activities as we're going forward. And in fact, Albert von Bargen from DLR, who I believe is also online today, is currently co-leading this task team on greenhouse gas with me. So this just shows that we have recognized that this is a very distributed problem with elements dealing with Calval, the actual atmospheric composition virtual constellation, and of course coordinated through the working group on climate. So there are multiple contributions, including on the side of the coordination group for meteorological satellites, and a strong link to the calibration efforts through GCOS. So at the moment we're developing a roadmap. So if I can have the next slide, please. There are obviously, as we've heard on many occasions over the last few days, very strong. There need to be very strong relations with the WMO and ICOS. We've participated in a number of discussions they've had in workshops and meetings. I think yesterday, we already in the question and answer, it was clear there are some very clear roles where ICOS can provide basically the main entity as far as coordinating some of the in situ networks, in particular for us to be able to access networks as well outside of the EU, and providing standards for this, as well as providing an advocacy entry point as well for encouraging parties to the convention to really build up those in situ contributions. And GEO as well, there was kind of a small rebirth of the GEO greenhouse gas and carbon and greenhouse gas initiative that's currently being reconsidered, and GEO they've established now a new climate working group, but we are definitely remaining open to that, especially because that makes a lot of links to the AFLU community as well. Next slide, please. So just quickly now, in finishing on the bilateral side, we've also been very engaged with a number of key partners. Japan is one partner I'd specifically like to point out. They have very similar kind of policy drivers to us, and there's a very close link, of course, between the space agency developments and what's happening in the Ministry of Environment in China. And they've been as well a strong partner in discussions in SUBSTA, in the research and observations subgroup, as well as in the TFI process. Of course, the GOSAT GW, which is hopefully coming after GOSAT 2, is really kind of a broad swath sensor that could potentially provide a lot of interesting avenues as far as thinking about how the MVS can assimilate this data. And we're preparing a Copernicus collaboration agreement. Now it's active. We have a Copernicus collaboration agreement with Japan, which explicitly mentions greenhouse gas monitoring. With China, we've had several encounters. UMETSAT actually hosted a workshop in 2018, and there's been explicit references in the civil space dialogues. With the US, of course, there is an existing Copernicus collaboration agreement and very strong working level cooperation. And of course, GeoCarb will be a first kind of geostationary mission that we can look at testing the monitoring and verification system with. Canada have a high elliptical orbit mission that they're interested in. But they're actually starting to position this now as complementary to the potential Sentinel constellation. So I think that's also interesting. So if we go to the next slide, this kind of just shows you, almost in conclusion, a kind of a summary of how we're trying to think about these things together. Of course, it's done from a Copernicus perspective, so the emphasis is put on that. In the top, you see kind of the Copernicus in blue at the top, you see the Copernicus monitoring and verification system and the input from the Copernicus Sentinels, but there's a wide range of third-party missions that we will take advantage of, in particular during the kind of prototyping phase, but also into the future. And also there's kind of an ambition on the longer term to think of even a geostationary ring that could complement these LEO satellite observations. Then, of course, the in situ contributions coming both from the GOR network as well as the European contributions through ICOS and other such things. So really, we kind of, when we're thinking of this system, is almost very similar to what we have in the context of the international, from a point of view in international cooperation, it's very similar to what we have in place, for example, for numerical weather forecasting. And you could imagine that there will be people who are not owning the space missions, but will want to run the data simulation and modeling systems as well into the future. So it's a very kind of ambitious and long-term endeavor. And my very last slide is just showing that this is not something static in time, that there's a timeline to this with commitments for the space segment from all of the key actors that we showed before. And so it's important to build up these corporations so we can really ensure we engage this in the long run. Thank you very much.
Thanks a lot, Mark. As usual, you're always providing some interesting views. I'd like to say Mark has been absolutely a key person and instrumental in having this initiative being taken at the international level, particularly for his contribution to CIOS and the responsibilities he got there. And he has been really leading this activity. Okay, so now we're ending the series of presentations, and we get into some general discussion. Before we get really in this discussion, we have, as we did yesterday, a poll, which we'll all invite you to contribute to. And maybe I'll ask the organizer to show you how that works to make sure there is no misunderstanding. Please.
Yes, thanks, Bernard. So I just activated the poll, so you will be able to see 5 different questions to which we ask you to answer, please. It's very easy during the live poll. You will see the questions, and once you answer them, just click send, and the results of the questions will be shown on the WebEx screen. I hope this is clear for everyone.
Okay, so we're going to monitor our votes. How does it go? Don't be shy. Feel free to express yourself and give your opinion and impressions on what we are doing. So we'll come back in a minute once you have been voting. Maybe in the interest of time, I think we dive in a series of very important questions that were asked. Maybe one of them, which is, I think, very important to all of us, is this question about how strengthening, the in situ networks, continuity of funding, sustainability, synergies. There have been many questions about synergies between TICO and ICOS. So Eric, well, I would appreciate if you could give us your view on that. How do you see we can do better from where we are now? Eric?
Yes, thanks. I put my video on. Yeah, thanks, Bernard. I think that the integration of TCON with ICOS is, of course, from a governance point of view, very favorable because it allows one entry point when it comes to dealing with all aspects of the network, and also in making sure that the combined network best responds to the requirements set out in the Green Report. So I think that step is very welcome and can be very useful in finding the kind of synergies we're looking for. I thought it was also very interesting the contribution from Agnès Robin this morning, where she talked about synergies in exploring synergies across a number of uses of the research infrastructures, and the objective to strengthen parts of the CO2 network infrastructure in urban areas. I think those are the sort of avenues of exploration that we are taking first and are the most promising. Hope that answers the question, Bernard. Perhaps you have your own reflections on this topic. Or do you want to go now?
Thanks, Eric. But I would be very happy to hear from Agnès on that. Agnès, if you can complement a bit, you have been showing some interesting ideas to go ahead, move forward. What do you think could do to make it better?
Sorry. Maybe just a reminder that your monitoring and research is not in principle the same budget. So it's not because one research infrastructure or several ones will further develop their synergies with, for example, Copernicus or all relevant initiatives for the CO2 monitoring, that still at the level of member states and associated countries, there should be a discussion on the funding for making these measurements really operational and fit for purpose. So what we are, for example, in the Green Deal call, what we are addressing is, as Werner said, that ICOS was mainly targeting the background information and to look more on hotspots and cities environment. It's required research to understand how to best do the measurement, which parameter to use, and that's an activity that we can support fully under the research and innovation funding. But the operation and the sustainability of this operation is still to be addressed, just to make the distinction.
Very, very important points indeed. Anybody else wants to comment on that point? Otherwise,
can I make a comment on this? This is Werner.
Sure, Werner. Yes, please.
Well, we have in ICOS, I would not say a problem, but a challenge that we are, since the beginning, somewhere at the border between monitoring and research. And I think we can easily agree that we don't have for the greenhouse gases some kind of a textbook or a cooking book that we can take from the shelf and say this is how we should do the monitoring. And so this monitoring and verification support system definitely needs a lot of research, and before we can fully implement it and have it operational. And I think that's the role of a research infrastructure, that we are providing the, let's say, hardware, the in situ observations, but also have the capacity to do the respective research in our, let's say, community. And I think that's, at least for the next decade, perhaps longer, is the role of the research infrastructure, that we have some kind of monitoring work to do, but also the research on top of it in designing the monitoring and in also designing the products and services out of the monitoring. And that's, I think, why ICOS and other research infrastructures are essential here. I would also, for example, mention EuroArgo or Actus and other research infrastructures. And but the problem is that what we want to achieve is perhaps not completely possible to get out of the research funding itself. So we need some kind of a mixed funding, even if it's for a research infrastructure that also gets some funding out of the let's say more monitoring related pots of funding, and that's definitely the challenge. We are depending in many countries currently on the funding coming from the research infrastructure programs or the research programs. That's very good because, as I said, we need a lot of research for this, but we might look for some kind of additional funding sources and some kind of a mixed funding, which we partly already have through the National Weather Services. But this is the challenge for the next month and the next years, in particular when it comes for the TCON ICOS integration. As I said, we are having a nice budget at the moment, but this is for these 130 stations and the whole data processing and coordination. If it comes to this integration, and that's our current problem or current negotiation situation, then we need funding on top of this. This is now going with the member countries. We have written a report from the ICOS community in a project. I've put the link on the chat, and the current situation is that we are starting the negotiations with the member countries to do this. Okay, very good, Werner. So we may move to a slightly different question, although they are not decoupled completely. I'd like to recast that in the context of the Copernicus program, which you all know is user-driven and policy-driven. And that particular context of the CO2, it really matters to make sure that we perform QA, QC, and fit for purpose exercise in a manner which is good enough such that we can bridge to the policymakers. Richard, you comment a bit and explain a bit what I would be to deal with this, what you call decision support system in the verification system that you are putting in verification support capacity with in place. Richard?
Yeah. So you want me to comment on the outputs, on the decision support and working with?
How do we ensure, the link? Because all what we do with the numbers and translate the numbers into something palatable and tailored to policymakers. That's I think the whole decision support system.
Yeah. Well, it's clear that just generating lots of output data is not sufficient. What we've learned in the past 15 years, basically already, for instance, within the build-up and operations of the Copernicus Atmosphere Monitoring Service, where we also interact with the policy community and other users, is that it's very important to look at the outputs together and see how we can make an interface that works. So for CO2 monitoring system, for us, it's crucial to work with the member states to see how we can develop policy relevant products that are easy to use. It's our job to crunch all the data, and it should lead to policy relevant useful information. But we cannot do this on our own. We need to work together on this. So that's why I stress the importance of kind of co-design the portfolio, co-design the policy interface. And in addition to that, this dialogue is also important because there are several countries developing their own observation-based monitoring systems. They have their own initiatives with maybe slightly different requirements than we have as a more European global system. But it's important to work together, first of all, so we know how we can support those activities, but also to learn from each other's expertise and even in terms of investing in the in situ infrastructure that we just talked about. Some countries might be very active on this, and we as a Copernicus program can benefit from that as well, and try to support those activities. So I think this dialogue is very important, and we'll do our best in the coming years to make this happen. But obviously we rely also on the buy-in from the countries.
Okay, I think that's clear. Okay, what I suggest that now we move to the outcome of the polls and see where we stand. The number of voting has been really stable in the last minutes. Okay, good. First one. So we had this question about how you rate the importance of in situ measurements, and Eric, you have to comment on that?
But now you have to remind me of the question because I was answering somebody in writing. I'm sorry.
Sorry, you have it on the screen now.
Yes. Oh, very nice. Yes. We are very keen with this workshop to get a feel for where we are with the in situ measurements and how people feel about it and what its value are. And this is very pleasing response, of course, from my point of view, to see that people think that the in situ component will be essential. Of course, we think so, and that's the message we try to convey through the Green Report and through our talks and discussions today. So it's pleasing to see that some of that information has indeed been that there's agreement around that, and I think that helps us to take these issues forward within the program. So thanks for that.
Thank you. Next question was very similar, but space-based. We got about the same sort of monochromatic view. Jessica, are you happy with that?
Yes, I see it's 2% lower than in situ, but yes, no, I'm very happy with this response as well. I think it shows the complementarity of the two systems, which is something that I've worked on for many years. We are really needing each other. I don't think anybody in the space-based business would say that you don't need in situ measurements. We always acknowledge this importance. And this is nicely coming out of this poll that we need both systems and in a complementary way.
Very good. Rudiger, are you able?
Yes, yes, I'm on, and yeah, I agree with Jessica. This is quite encouraging for us. You could I don't know if this is statistically significant, but maybe there is a little bit more hesitation here. But I can just say that this is a bit also understandable for what we saw today. The satellite component is now realized, as we saw nicely also in Simon's presentation, as a very useful additional component, which is in a sense also bringing new information and maybe partially surprising information, interesting information, which has to be interpreted. So in the future, and so. Yes, I'm very much looking forward also from UMIT's side on this in the WUR, and I hope we can fulfill the expectations there.
Bernard?
Yep.
You should tell Rudiger to keep talking. As he's talking, it's going up.
Okay, yes. Okay, for how long do you want me to go on?
No, it's okay. Now, maybe comment on these two questions. It shows, it illustrates, the sort of system approach that that we have been pushing. I mean, there is not one single solution in one given instrument type and so on. Next question. So is there a need for access to more detailed information, more results based time about greenhouse gas emission than is currently available from statistical? And here we have slightly different or more balanced opinions between essential and very important. Let's see. Hugo Denir, could you comment on that? You're still on. I did not check actually. Yeah, Hugo. No, we don't hear you. I'm not sure. Hugo.
Hugo is online. But
yes.
Okay.
Can you hear me?
Yes. What do you think about this outcome?
Yes. Well, I think. Well, first of all, yes. So many people see the need for that. I think that's the first observation. It is obviously a question on what you want to do, right? I mean, for the UNFCCC negotiations, annual results in the end are what you need. So there you don't need that. But if you want to be able to use observations and whether they are from space or in situ, we will need a much more detailed system that can cope with, well, hourly, daily, monthly values, because otherwise you cannot use we don't measure annual totals in the atmosphere. So in the light of the whole system, I think it will be critical, and I think people understand that when I see that. Well, that half says it's essential and 30% acknowledges it's very important. So I think the understanding of how we are going to do this is actually, at least in the community that is online, is really present.
I think this is also the beauty of this measurements we're making from space, because then we get coverage with very high resolution that could open new doors, in what's something that looks the scale of big cities or big power plants, and that's going to be
yes, exactly. I mean, just imagine that you are monitoring close to a power plant and that it is offline for 3 weeks or a month because of renovations or some repairs. If you don't know that, it will be really difficult to properly interpret the data that you see. So,
Joe, would you say something on that?
Hi, thank you. Yes, a couple of personal views on this one is that I think I will be in the block that says it's essential for several reasons. One is that the Paris Agreement, Article 4.1, identifies the need to urgently peak and then reduce emissions. And I think in order to closely measure that, this detailed information is essential. When is the peak? And then obviously we're moving towards net zero. And then, sorry. Voice is outside. And then my second point would be that in regards to the global stock take, we are looking, we must be careful that we clarify clearly between emissions and carbon dioxide concentration. But we're looking at, the Paris Agreement, which talks about a limit to temperature rise. So there's these levels of information that need to be carefully examined. And I think the more accurate you provide GHG emissions, the better you can look at in terms of ambition moving forward.
Okay. Let's move to the next question, which was slightly more technical. How would you rate the need for new networks such as radiocarbon And again, big mix between like 50% very important and 25 important, so it's not yet completely understood. Werner, what do you think? Should we keep pushing for this radiocarbon? Which to me is probably the only way to understand, you know, how good we are in actually decreasing our emissions at this global scale, not more regional scale. You know?
Well, I like this picture that Simon showed how radiocarbon can improve the modeling. I think it's definitely a very important and I would even say essential part of this whole ensemble of measurements. Perhaps one good news from our radiocarbon lab, they are at the moment working with air samples, but they have started an industry cooperation with a company that is making a constant sensor for radiocarbon. The signal is or the light signal is very small and very difficult to get, but the laser technologies are going on, and I think we might in 10 years time simply have another instrument in our racks where we can measure the radiocarbon. I think the information is very important also to distinguish between fossil fuel emissions and biological or biogeogenic fluxes. So I think it's quite important to have this measurement. Yeah.
Okay, thank you. We go to the next question, and the last from this poll. How do you rate the benefit to build upon international cooperation? And I think, and we have here, you know, very, again, solar monochromatic opinion being expressed. Simon, what do you think? I mean, as WMO, be happy with that?
Yeah, I guess I'm really speaking more for GCOS, but it's true for WMO as well. I mean, the whole benefit of international cooperation allows these systems to work. I mean, we can't really, the same as for weather, but looking at carbon fluxes, we can't just do it looking within a single country or a single area. We really need to have a much wider perspective. And I mean, not all countries can have their own satellites. We need to have cooperation across both the satellite and the in situ domains. So I think it is very important to think about this as an international exercise. And there are a number of international cooperation around, and I think they can be built upon and integrated to help actually this whole process move forward. But I think it is vital.
Yeah. Thanks, Simon. I'm sure Mark is going to be very happy to comment on that. He's up to speed. So.
Yeah, I've always been completely satisfied with very important. So 93% for the top two is I would say a clear indication that at least the efforts we've undertaken so far, and I think actually the workshop of the last 2 days has indicated some areas where probably we need to put a bit more effort, but I suspect that we're on the right path. And as I said before, it's not just the European institutions and agencies that have been involved in this, but many of the member state agencies as well have and are continuing to make very significant contributions on this. Thank you.
Yeah. Okay, so I think the main outcome of all these votes is basically that we are able to have the support from our participants up to significant level between essential and very important. So I have now let's have one more question to be addressed, and then we get to the sort of conclusions. There has been this point of once we have a calibrated system over Europe, the question is how do we deal with that? You know, if we have an overflow, let's say, of information over Europe, how do we make sure that the system is still okay and stable and ready to work when we go to larger scale? Richard, would you say something on that?
Yes, that's quite a general question. Obviously, what we have in mind is a system that covers the globe. We have satellite observations that cover the globe. We have in situ observations that cover the globe, but have areas where there are significant gaps that we have to deal with. So yes, the ambition is to provide products that cover the globe that can support all countries in the world, but it will come with different degrees of uncertainty based on the observations we have available, or for instance the priors we've discussed yesterday that are available. So the ambition is there, but we have to deal with these different degrees of coverage that are available. And at the same time, I think I just want to come back to the previous discussion. I think here is actually where the global collaboration is indeed crucial. This is something within Copernicus. Yes, there's a focus on Europe, and we can benefit from for instance, the relatively high density of in situ observations within Europe. But in order to make sure we provide something that's globally applicable, we need to work with other agencies around the world, with other countries around the world. So this is where international collaboration is key, be it through GCOS or WMO or CIOS. It doesn't matter so much. We just need to work together with the investment and the expertise that every single framework has.
Okay. Well, thanks. That's an interesting view. Okay. Before definitely closing, I'm very curious to hear from my friend Steve Briggs. Steve has been following the workshop from the beginning to the end, and I'm sure given the nature of the talk he has been doing yesterday, I would like to hear from you, Steve, about what you get from this workshop and what you think we could be doing better, and sort of things that we may be missing, and your other impression. I'll give you 2 minutes.
Okay, I'll be quick. I think there are 3 points that I would draw from it. Firstly, and this comes out from the Slido yesterday discussion, that's the Wordle, and that's the importance of a systems approach. And I think the Commission is to be commended in this, going right back to the first Blue report back in 2015, 2016, which identified a priori the need to address the problem of understanding emissions worldwide as a systematic problem, and not to try and address it part by part. And I think recognizing that fact and trying to address the problem, no matter how difficult, in an integrated way, taking into account of the satellite observations, in situ observations, the modeling, the simulation, right up to the decision-making process that Richard mentioned earlier. I think that was really critical, and I think Copernicus is unique in regarding this worldwide. Others are contributing, but I don't think anybody else, to my knowledge, worldwide, has set down and tried to build a systematic approach from the start. So I think that's really important, and that came across yesterday, I think, in people's responses as well. The second point, which I think comes out of this and others, is the sort of slightly worrying aspect that just how important this activity is. When we look at the Paris Agreement, the political and economic commitments which are being made by parties to the convention there, is all being based on the understanding of the emissions in the global stocktake that is going to come out from systems such as the Copernicus MVS. And that's an enormous responsibility to be placed on the science community at present. I think they understand it. I'm not sure if the politicians understand it, but I think it's a grave responsibility that we have. We have to get it right. And that's something that we need to be very cautious about the way we go forward. And I think the third point, which has been raised by a few people, is the fact that this is a regional activity. The whole activity, everybody involved in the Copernicus activities, all their acronyms begin with E, whether it's the EC, ESA, ECMWF, UMETSAT. And that's an important point, both technically, which has been touched on by many people. Some aspects of it are being quite well regarded. For example, I think the work on the satellite integration from other parts is probably quite well advanced. And the work that WMO is doing in atmospheric compositions with core, I think, is also advanced. But there's much more to be done globally in order to understand how this can be applied as a global system. And there's also the political aspect of the regional nature of Copernicus, which is who and where and how is going to take responsibility for implementing such an underpinning system within UNFCCC. Even if the EC or Europe were able to do that technically, then clearly the mandate, the political mandate, doesn't exist with Europe. That only exists at the level of the UN. So we need to understand how this would fit politically into a global system as well. So those are the 3 points I think that we need to consider, apart from all the very difficult technical issues. And I don't think any of us should be in any doubt as to just how difficult this problem is. To translate our observations of fluxes and compositions back to a series of emissions in the very stringent political climate in which we're having to do this, and one which is not getting any better, is a really tough problem. But we have to do it. And I think that the Copernicus program is at least as well advanced, well, I would say better advanced than anyone else in the world in addressing this at the moment. And you need to take it forward and keep going, because nobody else is going to solve the problem. So those are the 3 points I take. If I may, either small fourth personal one, which is that we need to consider methane as well at the same time. We talk about carbon being at around 450 parts per million at the moment, but if we include the methane contribution, it's equivalent to about 500 parts per million. And with the increasing extraordinary temperatures in northern Canada, northern Scandinavia, and Siberia at present, then the emissions of the methane are going to be even more important. I'm not sure how important, but worryingly very important in the future. And so a lot of clearly the transport and the modeling can be applied equally well to methane. But we will need to modify our observations to make sure we take that into account as well. That's a fourth ancillary point. But I think the 3 strategic ones are the system approach, the politics of dealing with the importance of the political information which we're generating, and the role that Europe has to play in a global aspect, both technically and politically.
Okay, thanks a lot, Steve. That's very good. Good thoughts. About methane, you know probably that methane is under investigation on our side. Well, definitely pushing for CO2, but methane is not lost. Methane is not forgotten. We'll try to, link with methane emissions in sort of MVS or similar to MVS option. This is one of the things that CO2 will investigate. The leadership of ECMWF. I'm confident we'll do something there, because we cannot do it as such.
It may be easier in some respects in that it's emerging that possibly the anthropogenic methane is less important than the biogenic methane, and therefore probably easier to deal with.
Well, easier, I'm not sure, but we may need slightly different observing system, but we'll do with what we have. And I'm sure we can make progress, and I'm confident that we can make progress in that. So thanks again, Steve. I think now it's time to start deliver the concluding remarks. I'd like to ask my boss, Mara. I've seen you connected, so I'd be happy to give you the floor.
Yes, yeah, I'm there. Can you hear me?
Sure, loud and clear.
Okay. So my conclusion will be in 2 parts, and I would propose that maybe the very final words will be for you and Hugo. But I think my conclusions for this workshop are the following: is that I was there in the beginning. From time to time, I was looking what's happening, and many people attended the workshop, even with peaks of 200 participants. And I think that despite the conditions, this is showing the real interest of people in not only the Copernicus program, but really on this very topic of CO2 monitoring. This workshop is not a one-off exercise. There will be several other occasions for that. It's clearly a fundamental political element for us, and so we'll try to organize such workshops on a regular basis in the coming years, taking into account that the system will be developed at that during these years. And for this, I would say that it will be a journey, but a journey that will be at the same time a sprint and a marathon. A sprint because actually we don't have much time in front of us in order to make it, and the marathon because I think the way will be quite long. We have many things to do, even though we have done a lot of things already up to now. I would also like to thank all the partners that have worked with us, in particular the European institutions and organizations who are joining us on this journey. Many of these also present during this meeting. And among those that are out of the Brussels bubble, I have to say, I would like to mention in particular ESA, EUMETSAT, and ECMWF for their very good cooperation. We have appreciated a lot of feedback from the participants. I've been in for the last 1 hour and a half. I've seen this interaction, and I think that this is very important, and I see a lot of support of what we are doing. We had a variety of questions and exchanges which I hope were answered appropriately. I will not conclude on the elements because it would simply, for me, read what colleagues has put for me. I think already Stephen gave some good feedback on the points, Bernard, Eric, and so on. And I imagine that there will be a report available out of this meeting, at least with the main elements. But what I heard as the outcome from the online polls have also confirmed that we are on the right track with our broad ambitions. The workshop was intended to inform the community in general, so those who are working on this aspect, but also the member states in particular, because we hope that we pass the right messages, and we need the member states because they are supporting not just financially but also politically, and this is how we need to work for the future. So this was the first part, so the workshop. Second part, Professor Pinti. So Bernard, I think, has been at the origin of all this. I think colleagues prepared for me some words, but I think that I don't need them. I remember when Bernard came to Brussels and joined my team, and we started to discuss together, and it was a discussion between a very committed scientist and a bureaucrat. And in the end, we were really matching together, and I think I learned a lot from Bernard. And at the same time, I have to say, Bernard learned how to bring these excellent ideas into political, concrete strategy. And through this way that I think he came up with a very good case, and he convinced me to put the case in front, first of all, of the director and then at higher level. And if we are here today speaking about satellites that will most probably be launched in 2025, if we are having these kind of workshops, if we have been able to raise money for this, I think it's thanks to this initial spark that was done by Bernard, and in the end, through this evolution, I think now there is a full community supporting us in this respect. So as most of you, Bernard will leave the Commission in September, so just after the summer break. So he will not be anymore in our team. I'm quite sure that it's not the last time we see him, because I think we cannot continue or afford to continue without his support in one way or the other. And I imagine that Bernard has already his contacts in order to continue to that. And we really hope that you will be part of this work. We hope as well that you will take time just to take care of you, not just of the work, so actually to enjoy the other part of your life. Now I will try something, and I think that the organizer will hate me for that, but I might ask you to unmute your micros. You can start to unmute them now, and then we can start to upload when I say 5. So if you can start to upload, so 1, 2, 3, 4.
Ça marche.
Good. So you can mute the microphones. Apparently, I didn't crash the system. That's it from my side. So I leave really the floor to you, Bernard, because I think it will be the best conclusion to the workshop. Bernard, the floor is yours.
Thanks, Mara, for these kind words. I mean, I don't know what I can add to that. Just let me say that it was indeed an interesting encounter, rencontre du troisième type between, somebody coming from the real science community and reading and talking with people who are extremely knowledgeable about all sort of procedures and ways by which we can implement programs. And I've been benefiting a lot, obviously, from many of the colleagues. I have to mention Hugo Juncker, obviously, who has been mentoring me for all these years. I learned a lot, also very, very friendly manner. So that's been quite appreciated. I had a lot of fun, actually. I had fun in Louis Sands, came to Brussels, I had fun as well. Different context, different people, but still enjoying what I was doing. I'm very pleased to see that, we're putting things into really concrete mode, with the CO2. I see that there is quite some interest. Really, I think we did the right thing by being very inclusive from the start, not only including the big E's agencies, as Steve was saying, European agencies, but also, industry, also, colleagues from research labs. They're trying to bridge all these people, and I think that's a really good platform that we have to do. So let me finish this workshop, end up with a series of thanks. First, thanks to all the attendees. I mean, they've been showing interest. They've been also contributing as much as they could, for this slide by asking questions and hopefully getting the response that were appropriate. Obviously, big thanks to all speakers. I think, quite honestly, we've seen very, very good talks, very good presentations. You guys have been very well prepared. Actually, that's an essential ingredient of the system that we have to deal with nowadays. I mean, being in a meeting as we are used to, meeting room, you see the audience, it's much, much easier than what we are doing now. Sticking on time and making sure that the slides go well. That needs extremely good preparation. We have been really, really good in that exercise. So big thanks. Obviously, thanks to the organizer, a special one to Theodora, who has been helping us, interfacing with MCI people, always kind and friendly interaction. And maybe the last one is for all the colleagues and friends for the invaluable and dedicated help, on what has been achieved so far. With that, I think that's it. And big thanks to all. See you soon.
Big thanks to you also, Bernard. Also from GRC for the networking and keeping the focus and we are very proud to have you with the highest policy impact as our GRC researcher there.
Thank you. Thank you. I will be around, so
yeah.
Don't miss it, but not miss that. I will be the dog watcher. So. Anyway, big thanks really to all of you guys. It was really, really, really nice. And I think we made it a success.
Thank you, Bernard, for organizing it. And there's also we will have another chance this week to say not goodbye, as you said, but to Wish you a lot of success in your in whatever you're going to do more for this.
Yeah.
In the work.
You're not completely done with me, and I'm going to to use what Steve has been privately sending to me. Steve, don't be offended, but he's writing something which is making quite some sense. Finally, your difficult character found a use. Thanks.
Thanks. Thanks for the workshop. Very well organized.
Yeah.
Thanks very much, Bernard. Ci vediamo.
Ci vediamo. Ciao.
Take care, Bernard. Talk to you soon. Ciao.
Ciao and grazie.
Ciao, grazie. Ciao, ciao.
Bye-bye, and see you next time. Cheers.
Yeah.
Bye, Hugo.
Bye-bye from my side as well.
Bye-bye.